When waves come together like this, they add when they reach the same space. It's called constructive interference. When waves are, as shown below, when they come together, they will cancel each other out. That's called destructive interference. So that needs to be remembered. So when we have waves of the same wavelength coming to two slits like this, what happens is when they pass through those slits, they are diffracted as shown. There's the crest of the wave. And they keep propagating out, but notice right here at this spot is where the crests overlap and you have constructive interference. There's another spot and another spot and yet another spot. And they will keep giving this constructive interference. But that's not the only place where it happens. Look at this wave carefully. There's one there, there, there. And in fact, if I were to draw a screen at the top and pretend this was light waves, you would actually have constructive interference at all these places shown by the arrows, and you would have what's called a fringe of light. You have the bright spot and then a dark spot. Bright, dark, bright, dark, bright, and etc. It keeps going. They're called fringes. And you have to have light of the same wavelength, monochromatic light they call it. There's the light going through the two slits, and there is the interference pattern. Now we want to derive a formula that will tell us where the fringes are. So here's another way of looking at this. Here's a ray of light coming in, and it is diffracted as shown. Another ray is diffracted, and there will be a ray diffracted such that, look, all of the crests of those waves will do constructive interference as shown there. And follow this carefully. In order for them to have constructive interference, the one that has bent like this in the bottom has to have one wavelength or two wavelengths or three wavelengths so that the wave is perfectly in sync with the top wave. It's in phase with it, we say. So let me label this, and that will be n lambda. So let me simplify this diagram. I'm going to draw a red line there, and the dotted line is shown. That yellow line represents the first diffracted ray. Here is the second diffracted ray. I will call the distance between the slits d. The length from the slit to the screen is L, and it's huge compared to D, 10 to the 5th times greater sometimes. And we will call the distance from the dotted line up to where the first fringe happens Y, or to the second fringe would be Y. We'll call that Y. There's n lambda and a little right triangle there. There's theta, and here also theta will be in the little green triangle. So look at this diagram, copy it out carefully. That dotted line is called the central maximum, and all the fringes are measured from the central maximum, and they would call that actually n equals 0. Now I want to derive the formula now, and y over L equals tan of theta, opposite over hypotenuse. But notice something. For small angles, the tan of theta equals sine theta. Now, if you have trouble believing that, take your calculator out and try tan 0.5 degrees, then sine 0.5 degrees, and you'll see that for really tiny angles, they're the same. And theta, in fact, here will be very, very tiny. So what I can actually say is the sine of theta is y divided by L. Now, what that means is there's theta right there, that little check mark I put in purple, and I can say n lambda over d, opposite over hypotenuse, is equal to the sine of theta. And therefore, I can say n lambda is equal to d sine theta, and that's one of the very important formulas. We'll look at that in a moment. But now I can also say n times lambda is equal to d times sine theta is the same as y over L because the angle is small. And now I can rearrange that formula for y, and I will have an equation that will tell me where the fringes are to be found relative to that central maximum. Very important equation. NL times lambda divided by d. That's what y is. Now let's look at this a little bit more carefully, and I'll just identify and clarify what each variable means. Now they usually write the formula with an m instead of an n. And m represents an integer, 1, 2, 3, 4, 5. For example, the first order fringe, where the first bright light is the first order. The second fringe would be the second order, where m would be 2, etc. If you wanted the dark spot, you go up by halves. Lambda is the wavelength. D is the distance between slits. And obviously theta, sine theta, is the sine of that angle from the center of D to the screen is shown. But more important now, y is the distance from the central maximum to whichever fringe we want. It's the distance. Now remember to keep the units the same, by the way. And that will help you to find y, and you need to memorize this formula. M, as we've talked about, is an integer, 1, 2, 3, 4, 5, that tells you which order you want, which one of the fringes you want. Lambda is the wavelength. L is the distance from the slits to the screen. And D is the distance between the slits. You really need to know how this formula works.